All right, guys, so we're back. This is Otis again, and what we have today, we're going to be demonstrating our buffers in action experiment. So, our first video was just some background information on what is an acid, base, and a buffer. And so now we're actually going to test out three different um, buffer solutions. Now, I'm sorry, buffer chemicals that we're going to try out, and what we want to do is determine which one is the best buffer. So we have buffer one. Selena, can you hold up buffer one? And buffer one is dry milk. Okay. Buffer two, can you hold up buffer two? That is Kool-Aid, tropical punch flavor. And our last one is Gatorade. So that's buffer three. So basically, we want to determine which one of these three are the best buffers. Now, does that mean that they all are buffers? Not necessarily. That means that out of the three of these, one of them is going to slow down that reaction between baking soda and lemon juice the best. Okay? And how we can measure that is basically by how long the bubbles that form stay in the beaker. Okay, that's one thing that we want to check out. And then the other thing is the actual reaction time. We want to see how fast are bubbles able to form. If they're able to form very, very, very fast, then we know that maybe this is not a great buffer. Okay. All right. So we're gonna try out these three. The first thing we're going to do is add 20 milliliters of lemon juice to our graduated cylinder. Okay. And we're going to add this 20 milliliters of lemon juice to each one of our beakers. So that's our first one. So second one. And our third. Okay, perfect. Okay, so at this point, we've added our acid, so we're done with our acid. We can put it away. We have an even amount of acid in each beaker. Our next step is to add a buffer to each one. We're going to add our sample buffers. So to our first beaker, we're going to add half a teaspoon of dry milk. Very good. Okay. And then to our second one, we're going to add a half a teaspoon of Kool-Aid to our next buffer. Okay, and then we're going to add half a teaspoon of Gatorade to the last beaker. Okay, good. So we have half a teaspoon in each beaker. We have even measurements in all. Okay, so that means we're being consistent. So the next thing we need to do, we need to break up those molecules inside of our sample. So what we're going to do is we're going to grab a spoon. We're going to place a spoon into each beaker. Okay, so we're keeping everything consistent. And we're just going to start off with each one, and we're going to just stir them for about 10 seconds. So we're going to start off with our first sample. We're just going to stir it for about 10 seconds and make sure that we break up a lot of those clumps and try to get it to dissolve as best as we can. And what that's going to do is just going to spread our samples as much as possible. I'm just going to break it up so that way it can dissolve inside that liquid, which is what you want. You want as much of it to dissolve so that way you can actually see the buffer effect. Okay. So we're stirring up our second, just making sure we are mixing and distributing all the molecules in our liquid sample. Okay, so now we're at our third. Okay, great. So all of those large samples that we added have been dissolved in the liquid sample. Okay, so right now we have our buffer samples along with our acid, the lemon juice. Okay, so what we're going to do next is we are going to add our base. We're going to add the baking soda. So we're going to open that up. And we're going to add it starting from our first one to our last. And we're going to see what happens. So first, let's pause. We're just going to take a look at this first one. So the first one, we already see there's a reaction, right? Selena, are there a lot of bubbles that are forming?
Not as much as with only the lemon juice.
Not as much. Okay, good. As compared to the lemon juice with the baking soda, yes. So there's not a lot forming. And what I can also tell is that it seems to be going pretty slow. So the process seems to be happening just a bit slowly. Okay, so next we're going to add our base to our second sample. So another teaspoon to our second sample. What do we notice about this one, Selena?
It's much slower than the first one.
Okay, so we notice that this one is occurring pretty slow. The bubbles seem to form pretty fast though.
Yeah.
And we can see that the bubbles are also, they seem to be popping a lot. So it's producing, we see that it's producing a high amount of CO2. Okay, so now we're going to add to our last one. And this is a teaspoon of baking soda.
Yes.
All right, so this one seems to be happening a lot faster than the last two. Okay, do you agree, Selena?
Yes.
Okay, and so this one is forming a lot of bubbles, and it seems to be actually producing a little bit more bubbles than the last two. It's still forming. Okay, good. All right, and so basically we've done the full experiment, and see the last one is actually forming more bubbles. So it's getting pretty high. Okay. Good. So right now we can just kind of look and just kind of guess which one do we think is producing the most bubbles for the longest period of time. Now what we can see is that some bubbles look a little bit thicker than others. So looking at this first sample, those bubbles are pretty thick. The second one are not so thick, and they actually look to be dissolving pretty fast now. It's going down. And then the last one, after it produced a lot of bubbles, the reaction seemed to have stopped. Or it's still kind of going on, not as fast as when it started. Okay, good. And so those are observations that we want to make after the experiment. Another thing we can do is we can actually smell each of the beakers. And so just kind of go up to it and waft it a little bit, Selena. Okay, and so because of the different types of buffers that we use, there's other properties that you can give off, and so one of those is a smell. It gives off an aroma, okay, because of the type of samples that we're using. Then the last thing at this time, we've looked and we made observations. We've also smelled them. Now one other thing we can do, we can actually listen to see how the reaction is going. It's been about a minute since we've added all of our samples, so Selena, can you lean in and just listen to see? Pull one close to you, a beaker close to you, and just see which one is making the loudest noise.
Yes. One of these two.
Those two, okay. Oh, great observation. So Selena noticed that our last two samples are still making noises, which means that the neutralization reaction is still going on. And then for the first sample, our first buffer, she didn't hear very much, which actually means that it's still neutralizing, but at a very, very, very slow rate. So I think we have determined our buffer, and the buffer that from these samples, which is the best buffer, is our buffer 1. So this buffer has produced bubbles, or pretty tough bubbles, which still have formed for a longer period of time than the other two. And then the secondary observation that we made is that the reaction time. So we are unable to hear very much from the first sample. The other two, we can still hear the neutralization reaction, which means that that buffer was able to even out that neutralization reaction. Okay, so the last thing we want to do, we can actually make comparisons. Selena, can you grab that sheet over here? And basically, it just compares different systems in our body that acts like buffers. So our lungs, they act as buffers, right? We breathe in O2, we breathe in oxygen, and we release carbon dioxide. And our lungs actually have to have the capacity for both, for oxygen and CO2. And it has to be able to balance that. It has to be able to absorb one to release the other. Otherwise, our lungs can be harmed in that way. And so it has to be able to act as a buffer in order to stabilize the two different components that are coming in and out. And another thing is our kidneys. Our kidneys work as amazing buffers. If you think about all the things that we eat throughout the day and all the things that we drink, they basically consist of acids and bases. And your kidneys work to filter out all of those substances that we eat and that we drink. Okay? And so pretty much there's more information on the back, on the front, just of how the types of acids that are in our bodies, and then how we help stabilize these acids. So this is why buffers are so important. Our kidneys, our lungs, our muscles, our stomachs, everything in our bodies operate at a certain pH level. If there's